and welcome to the first session in a new series of training, where we'll be taking a more technical look into artificial intelligence. My name is Matt, and I'm part of the data science and machine learning team here at Deal.ai. These sessions are designed to complement the regular software agency sessions, and whether you're looking to create AI apps for your own business or work as an agency to make AI apps for other businesses, it's important to have some technical background on AI for several reasons. First of all, understanding the capabilities and limitations of AI, as well as getting a feel for the future trajectory that it might take, will help you to work out which of the use cases you identify as being desirable are the most feasible and viable, as well as allowing you to guide your clients with confidence. Secondly, having a background understanding will help when it comes to communicating with the development and engineering teams who will bring your product ideas to life. These sessions will start at an introductory level and move gradually into increasingly technical topics and end up in the creation of an AI app. In this session, we'll cover a few topics. We'll briefly look at the history of AI with a view to understanding why now. By which I mean, why is it that when AI has been researched since 1956, was there a huge breakthrough in capabilities and an entry into the public consciousness in 2022? And why are we having these huge advancements on a seemingly weekly basis ever since? We'll take a look at some of the topics that are under active research and maybe do a little bit of crystal ball gazing into what might be coming through the pipeline in the near future. We'll do some level setting with some important AI words and phrases, which will give you the terminology that you need when communicating with others about AI. We'll get an intuition about how the most common type of AI in use today, GPTs, work. And we'll finish off with a quick look at how to directly interface and with how to interact with an AI model at a more direct level than you'll get with a tool like ChatGPT. If you listen to all of that and thought that none of this is new to you, then don't worry. The upcoming sessions will get increasingly in-depth as time goes on. And similarly, if there's a topic that we cover today that you'd like to go into more detail on, then let us know through the regular support channel. So how did we get to where we are today? Well, when a group of the brightest minds in the world at the time met at Dartmouth College in New Hampshire in 1956, they said that they were going to try to find out how to make machines use language, solve the kinds of problems that only humans can solve, and to self-improve the machines so that they could work on themselves and make themselves better. They genuinely thought that they would make a significant advance in one or more of these programs if they brought together a carefully selected group of scientists for a single summer. And clearly it took ever so slightly longer than that, but it's fair to say that a significant advancement has actually been made. AI is now able to use language and do a lot of things that previously only people were able to do. In the early days of AI, things tended to be very specialized, and AI is focused on one thing and one thing only. And a really good example of this is IBM's Deep Blue chess computer, which you may remember. Back in 1997, it became the first computer system to beat a world champion in a match under standard chess tournament time controls. Deep Blue was incredible at chess, but that's literally all it could do. It couldn't engage in a conversation with you, it couldn't write essays, or do any of the other incredible things that we've kind of come to take for granted with modern AI systems over the past couple of years. So these days, you'd hardly call Deep Blue an AI. It tends to be the case that as soon as we kind of become used enough to an AI breakthrough, we stop calling it AI and just call it technology. So it'll be interesting to see whether what we call AI today will be qualified and actually have the label of AI in a few years' time. The key development that unlocked the potential of modern AI was a research paper published by Google in 2017 called "Attention is All You Need," which introduced the transformer architecture that's the basis of systems like GPT. And in fact, the T in GPT stands for transformer. So what is a transformer? Well, it's an architecture that lets AI models understand the context and the relationships between different parts of the things that you put into it in a way that just wasn't possible before, by letting it pay attention to different parts of the text and adjust the outputs based on that. So you don't need to delve into too much detail about what the transformer architecture means, but it's good to know that that's what the T part of the GPT stands for. And another really important factor is the crazy increase in computing power, especially GPUs or graphics processing units. So you may have a graphics card in your gaming PC, and you've definitely got one in your PlayStation, Xbox, or other games console. And these were originally designed to kind of draw the graphics of games, but it turns out that they're also really, really good at the kind of math that's needed to train large AI models. And the largest AI models, things like GPT-4, are trained on huge clusters that contain thousands or tens of thousands of these top-end GPUs, significantly more powerful than what you'd find in your PlayStation or Xbox. Each single GPU used in AI model training can cost up to $40,000. And a single training run for GPT-4 was estimated to have cost around $100 million and took months to complete. And Anthropic's CEO, which produces the AI model called Claude, which we'll go into a bit more in a future session, has estimated that the next round of AI models may take upwards of $1 billion each to train in terms of hardware, power, and time. But the sheer amount of talent and capital that's now flowing into AI research today means it's absolutely the best possible time to be in AI, or at least to date anyway. And just to take a quick look back over how far we've come, this graphic shows what image models, which we wouldn't even call AI today, the first image models using neural nets, were able to produce in 2015. It's hardly something that's recognizable, but this was the first time that computers could kind of produce images on their own based on the inputs that you gave them. Fast forward to just over 2 years ago, this is the first output from the Midjourney image model, the first version of that. And this is exactly the same prompt on Midjourney today, a little over 2 years later. So it's easy to get caught up in the flow of AI and sort of think, well, it doesn't quite get the text right, or it draws something with 6 fingers, which actually has pretty much been solved, but that was a huge issue even less than a year ago. But looking back over the kind of progress that's been made in the last 2 years is absolutely outstanding, and even more so if you look at less than 10 years ago. So let's imagine where we'll be in a few years' time. One of the hottest areas of AI research right now, and when I say right now, I mean when I recorded this video, as we discussed, AI is moving so quickly that by the time you watch this may have already been fully researched and out on the market. It's hard to say. But if you're watching this close to when it was recorded, one of the hottest areas of AI research right now is agent-based or agentic AI. So this is the idea of creating AI systems that can take actions by itself to achieve high-level goals that you give it. So if you think of a current AI like ChatGPT, it can engage in conversation with you and help you with tasks kind of step by step, but it will only respond directly to your prompts. The vision for agentic or agent-based AI is to create systems that are able to independently carry out tasks and actually start to make some decisions to achieve the objectives that you give them. So you can give it a really, really high-level task like write me a financial report, and it would go away, it would do the research. If it needed more information, it would come back and ask for that information. It would collate everything. It would write the report from start to finish. It would seek feedback. It would iterate and improve the report. And it can kind of adapt that to pretty much any task that you give it. And the more advanced these agents become, the more difficult the type of task that they'll be able to tackle. Some researchers believe that we could see agentic AI within the next 5 to 10 years, and that would be a huge leap forward in capability. Another exciting area is video AI models. You may have heard of Sora. You may have seen some clips from Sora. Unfortunately, as at the time of recording, it's not out for the public use yet. It's undergoing testing and what's called red teaming. which is where they get security companies and individuals and researchers in to try and find vulnerabilities that can be exploited in the models, so they can make sure that those are removed before it's released to the public. But anyway, other companies other than AI are also working on AI models that can understand video and generate video in the same way that current models like ChatGPT and GPT-4 and Claude, etc., work with text and images. And as these video models become more advanced, they could open up really, really incredible possibilities, like generating whole custom movies tailored to your interests. So imagine it kind of looking over your likes and dislikes over Netflix, over Amazon Prime, over Disney Plus, whatever services you subscribe to, getting a feel for what kind of movies and videos you like, and then just generating fully custom films based on your own interests. While we're talking about things like video models, etc., it's also worth talking about the concept of multimodality. So a modality when it comes to AI refers to the type of information that it can work with. So for instance, the GPTs, for example, work with text in, text out. They can also work with images in, text out. Other types of modalities are images, audio, video, etc. So most current AI models that are on the market specialize in one or two of those modalities. So they might be language and vision models, for example. But there's a lot of work that's going on into developing multimodal AI that can understand and work with a load of different types of input and a load of types of different outputs in an integrated way. So kind of similar to how, I can take in information from text, I can take in information from images, from what I hear, from what I see, in terms of sort of video and images, etc., and draw insights from them, and then also respond in various ways, whether that be by voice, by writing, by drawing, by taking action in the world. So that will be another step in improving and integrating the modalities that AI models can work with. And the idea is that the more modalities that a model can work with, the more true understanding that it kind of has and is able to model the world in a more comprehensive way. And these things together, the kind of multimodality and the agentic AI and a load of other breakthroughs in research, a lot of people believe that that's going to lead to the ultimate goal that many AI researchers are working towards, which is called artificial general intelligence. So that's AGI. So AGI, the definition of AGI is an AI system that can match or exceed human intelligence across any task, whether it be, like I said, writing a financial report, drawing a painting, coming up with a novel scientific theory. And then if you have an embodied AI, so an AI that sits within a robot body, for example, you could say, go and bake me a cake. And it would kind of work out everything that it needs to do. It would navigate around the kitchen, a kitchen that it's never seen before. It could find the fridge, it can find the ingredients if it's never actually been in that environment. So it will be able to generalize that knowledge and do entirely new things, the same way that I could. I can learn a new skill. It might take me a while, but I can learn it in AI. And AGI might be able to learn that faster than I can. And that's one of the key things around AGI is that self-improvement, that generalization, and being able to do tasks that people can do at the same level or better. It's not known currently whether AGI is even possible. It's not known whether the path we're on with transformer models, diffusion models, etc., would actually ever lead to AGI, or if we need some more breakthroughs to get there. My kind of gut feeling is that we do need more breakthroughs, some more fundamental breakthroughs, in the same vein as how the Transformers paper led to the current crop of AI. We probably need at least one, two, or maybe a few more before we can get to AGI, but I'm willing to be surprised. But whether AGI is possible and how long it might take to achieve, it's a huge kind of intensive debate that's taking place with experts. We've got predictions ranging from Elon Musk's kind of 1 to 2 years through to people saying a few years to a few decades, and then people on the other side of the argument who are saying it's just not going to happen. If AGI does actually end up being developed, then of course that's going to be a huge breakthrough, and that's going to have unprecedented impacts on our economy and society. But to be fair, even if AGI is still a long way off, then the kind of more narrow AI systems that we're developing today are already unlocking incredible capabilities that will transform pretty much any and every industry that they touch.